So hello everyone, we welcome all of you to our next one more session about science behind colors and ice cream under the Science Studio. And we have our speaker here today with us, Dr. 𝐃𝐞𝐬𝐜𝐫𝐢𝐩𝐭𝐢𝐨𝐧. She is the PhD candidate from Department of Chemistry, University of Victoria, Canada. And she is a trained photochemist. She is passionate about science communications and outreach. She is also a co-STEM specialist at the BC Girls Guide Program Committee, where she actively works on designing and developing STEM experiments for girls with a goal to simplify complex scientific concepts. So in today's session, we have two different layouts. In first layout, Sri will be talking about the color, science behind the color, science behind ice cream. That would be our first session. And you will also get an opportunity for making your own ice cream. It will be like a hands-on activity. In the second session, or second part of this session, she will be talking about the science or chemistry behind colors. And with that note, I will leave the floor to Sri. And also, all of you, please note that this session is going to be recorded, will be uploaded on YouTube, and we will share the link with all of you. If you have any question during the session, you can always unmute yourself or raise your hand, and you can ask your question directly to Sri. So Sri, thanks a lot for coming today. I understand it's a very busy schedule for you because you're just near the end of your PhD thesis. And I really welcome you from my heart, and I will give the floor to you. You can start the session now.
Thanks, Noen. Hello, kids, and thanks, Noen, for the introduction. You know that I'm a scientist in training. I shouldn't call myself as a full-fledged scientist, but I'm a scientist in training. So we are here today to explore the science behind ice cream and also the science of colors. So let's begin the session asking some simple question. What's your favorite ice cream flavor that you like? You can let us know in the comments. What's your favorite flavor? My favorite flavor is definitely chocolate. Anything that has to do with chocolate, I totally like it. So I'm seeing that someone has commented butterscotch and caramel. You can all let us know in the comments which one you like. We'll just give 2 minutes. Chocolate, yay, chocolate. I also like chocolate. Toby. Mango, vanilla, nice flavors. Pistachio and chocolate. Cotton candy, so cool. Strawberry, okay. That's great. So you all have different taste flavor buds. I believe someone likes fruit-based ice cream, someone likes chocolate ice cream or vanilla ice cream. So we're good. But today we're going to make a banana ice cream, which is again a type of fruit ice cream. I mean, bananas are everywhere, so it's such a simple thing. It's very easy to make a banana ice cream than dealing with an apple ice cream, which I don't want to deal with the session today. So to begin with, let's get back and quickly understand what is in an ice cream. So what do you think an ice cream has? Again, you can let us know in the comments what you think an ice cream has. It's sweet, it's fatty, so you can think of like you can comment what do you think an ice cream has. So I'm just looking at the comments. I'll give you 2 minutes to comment milk. Yes, that's correct. That's the fat component in an ice cream. Milk, butter, sugar. Yeah, sugar. Yeah, it's sweet. So there's sugar in it. Cream. That's so correct. Ice cream, right? But you're missing an important part in an ice cream. You covered cream, but you didn't cover ice. Yes, exactly. There is an ice component, which means there's water in ice cream. So the major part of an ice cream is just water. So it has water, it has cream, it has sugar, and it has some milk solids, which basically, again, like it's a way of like adding texture to the ice cream. Apart from this, the ice creams that you get out in the shop also has compounds called emulsifiers. I will explain you what an emulsifier does during the session. And also people add flavoring agents to an ice cream. Like today, I'm gonna add maple syrup into my ice cream, which really gives me that flavor to the ice cream. So Great. So we all now know what ingredients an ice cream has. Let's think about what each ingredient does. So what do you think sugar does to an ice cream? This is a very simple question. You all know what sugar does to an ice cream. You can comment and let us know what sugar does to an ice cream. Exactly, it makes it sweet. And it makes it sweet, yeah. And does anyone have anything else to add apart from it making it sweet? I think most of you say it's more liquid, it makes it sweet. All good responses. So let's see what sugar does to an ice cream. Yes, totally, it makes it sweet, but there is one other thing that sugar does. So like I said earlier to you, the major part of an ice cream is just water. So you take when you put water in cold temperatures in the freezer or the fridge, it freezes, and you get ice from it, right? So what sugar does is it reduces the freezing point of ice. By what that I mean is, let me give you some example here. It's snowing everywhere near your house, and you see some municipality workers will put salt on the snow when snowing all around you. You know why they put salt on the streets when it's snowing? You can let us know in the comments if you know why. I'll wait for a minute, and if you don't know the answer, I will tell you why. Okay, to melt the snow, exactly, to melt the snow. So what salt does, like when they put salt on the roads, when you have a snowy day, the salt reduces the freezing point of water. So instead of, so what happens by that is, like, you start to melt the snow because the freezing point of water is reduced. The same concept holds for ice cream too. You don't want your ice cream to be solid, right? Like a very sticky solid that you can't bite in it. You want it to be creamy, right? So what sugar is doing, apart from providing sweetness, is it's trying to reduce the melting point of ice so that it doesn't form a hardcore ice cube in the ice cream. So it's just makes it more creamier. So that's what sugar does. So let's take a step back and see what milk does to an ice cream. What do you think milk does to an ice cream? So again, you can let us know in the comments of what milk does to an ice cream. And I'll wait for a minute. Don't be shy, you can always comment, and there is no right or wrong answer here. You can just makes it creamy. Yeah, that's what the milk does. It makes it creamy. The milk has something called fat, which is what makes ice cream doesn't taste like ice, because the fatness is what makes it more delicious. I feel you don't feel like you're eating like an ice cube. You feel like you're eating something else which is frozen, right? So that's what milk does. The milk, what it does is, because it's a fat, it keeps the water in the ice cream separate. So water contains small molecules called H2O. So when these molecules come together, they freeze and you get ice. So what milk does is it kind of starts to make friendship with the water and keeps water molecules away from each other. By doing that, it's preventing water to form a hardcore ice. So again, milk, apart from giving you the creamier texture of ice cream, what it also does, it's keeping the water molecules away and making sure that the ice cream doesn't become a solid ice, right? That's what milk does. Okay, so what else is left? We talked about milk, we talked about sugar, we talked about water, and what else is left? And cream? Yeah, we kind of covered that too. So let's take an example of ice creams that we all see around us. We see a popsicle, which is a hard ice cream. We see cornetto, I think, which is the one you get in a cone. That's an ice cream that you get. And also you see gelato, right? I love gelato. Yeah, we see kulfi too. Totally, I'm a very good kulfi fan. So the gelato and popsicle, when you imagine a gelato and when you imagine a popsicle, what's the difference that you see between both of them? You can again let us know in the comments of what you think is the difference between a gelato ice cream and a popsicle that you eat. I will wait for a minute. If you don't know the answer, that's okay. Yeah, one is very solid, exactly, and gelato is more creamier. More water in the pops, that's correct. There's more water in pops, and that's why you see it very hard compared to gelato, because it's more creamier. So we all know that there are tricks that you can add to water to make it to avoid it turning into a solid ice, right? So I told you, like, you add sugar to make sure that it doesn't turn into solid ice. You add cream, you add milk solids, and all these basically does the same job. But there is an important thing that that differentiates between a popsicle and a gelato. What it is the freezing time. When you freeze a popsicle, you put it in the freezer, you leave it overnight, and you eat the next day, which means you're actually leaving the popsicle for a longer time to freeze. You're freezing it for a longer time. Whereas for gelato, how people make gelato is they make it the freezing time, once they make the mixture, the freezing time they allow to form gelato is very short. In some ice cream companies, they make gelato within seconds. They just freeze for a few seconds and then they make gelato. So basically, the differences in freezing time is what makes a popsicle so hard and gelato so soft and creamy. So why is that? When you have a longer freezing time, you're getting a hard solid, and when you have a shorter freezing time, you're getting a creamy texture. The reason there has to do with something called crystals. So water, you all know water. So water, when you cool it down, it forms crystals, the snow crystals that you see in a Frozen movie. You know what I'm talking about when I tell you crystals, right? So the crystals, in the case of a popsicle, you have long crystals, whereas in the case of gelato, you have short crystals. And the reason why the popsicle forms a long crystal is because you're freezing the popsicle for a longer time. You're freezing it overnight so that it forms a beautiful long crystal. Whereas for the gelato, your freezing time is very low, so that it doesn't have the opportunity to form a long crystal. So in gelato, you form small crystals, and that's again brings a difference in the texture. So I told you that freezing times makes a lot of difference in an ice cream, right? So why don't I show you how actually someone freezes ice cream in seconds. So I'm gonna quickly share you a video of this. Can you see my screen? Sorry. So I'm going to quickly show you how they do liquid nitrogen. They freeze the ice cream in such a short time. So if you see, they make their ice cream mixture. And now what they do is they're pumping something into the ice cream mixture. And once they pump it, they're just mixing it again. They're mixing it all together. And I'm going to fast forward it for you. So that's what they get. They get ice cream. So if you see that within few seconds, it turns into an ice cream. So that's the ice cream that you get. So the one that I showed you, what they're doing is they're using liquid nitrogen, which is something that we chemists use in the lab. So what liquid nitrogen does is it freezes something very fast. So if you take some water and pump some liquid nitrogen into it, it turns it into a solid within few seconds. And that's a technique that some ice cream vendors use to freeze the ice cream in such a short time. So you get that creamier and more liquidy texture and not like a rock solid texture, okay? So I'm gonna stop here and I'm gonna ask if anyone has any questions before we actually move into the ice cream making part. And we also will understand who actually invented ice cream. Like we wanted to know who invented ice cream, who's the genius. So if you have any questions, do let us know in the chat until now, or like you can raise your hand and you can ask me questions. So we will see for 2 or 3 minutes to see if anyone has questions, and we will move ahead. I think everyone is doing okay. Great. So why don't we move ahead? And again, you always have time to ask questions during the session. So if you don't have anything now, you're always welcome to ask questions towards the end of the session as well. So let's move to the ice cream part. So Noan has sent you the list of ingredients that we need to make an ice cream today. So I have all my things with me. So if you're making the ice cream with me, make sure your ingredients are kept close to you and follow my instructions. And those who don't have the ingredients, just feel free to watch how I'm making it, and you can make it when you have the ingredients, right? So first, I took 2 frozen bananas and I put it in my blender. So I actually peeled the bananas and I put it into my blender. So if you have bananas, just peel them and put it into your blender. And I'm gonna give you a minute to do that. And in the meantime, so what is bananas doing? Like here in this ice cream, it's providing sugar, right? Like that's what bananas does. Yeah, 2 bananas, exactly, that's correct, Darren. If it's frozen, very good. If you don't have frozen bananas, you can use normal bananas. That's fine. Because I think frozen bananas have more sweetness than the normal bananas. So I prefer frozen. So once you take 2 bananas into your blender, the next thing is take a cup of yogurt. So you can take Greek yogurt or any normal yogurt. So I took a normal yogurt that I get. I didn't have Greek yogurt at home. So I'm just taking 1 cup and I'm going to quickly transfer it into the blender. So the yogurt is a kind of replacement of milk. So I'm not a milk person, I'm a yogurt person. So I decided to add yogurt. And again, it's the creamy component that does what I told you earlier to an ice cream. So once you added your yogurt and your bananas into your blender, it's time to add some buttery component, which is peanut butter. So I understand some of you might have peanut allergies, so you can use almond butter if you would like to, but if you don't have any butter at home, you can ignore it. That's fine. It's not gonna, it will be more creamier if you add butter to it, but don't add actual butter. If you have peanut butter or almond butter at home, just use those. So I'm gonna add 2 tablespoons of peanut butter. So it's just like I took a spoon and I have 2 spoons. So once I added the peanut butter, So what all I have in my jar are 2 bananas, 1 cup of yogurt, and 2 spoons of peanut butter. So now I'm going to add some vanilla extract. Again, vanilla extract is a flavoring agent, so you just need some drops. So I'm going to add like 2 drops into my blender. So the vanilla extract is done. The next step, I'm going to add some maple syrup. Like I said, I'm a maple syrup fan, so I'm going to add like a tablespoon of maple syrup. So this is a mixture now. So we have like fat component, which comes from yogurt. We have water, which comes from yogurt and the bananas. We have buttery component, which comes from the peanut butter. And we also have sugar, which comes from maple syrup, and vanilla extract, which is just flavor enhancer. So we have everything here that's required to make an ice cream. You don't need to add any extra sugar to this ice cream. I wanted to make it healthy, so I decided to ignore white sugar. So I just used bananas and hoping that bananas would have enough sugar to substitute for it. So once you added all your ingredients into the jar, it's time to turn on my blender. So I'm gonna mute myself.
Hello everyone. While Shri is blending the ice cream, who is actually making ice cream? Oh wow! Okay, we will see. So Shri is.
I blended all my mixture together. So like I told you, it has 1 cup of yogurt, 2 bananas, 2 tablespoons of peanut butter, some maple syrup, and 2 drops of vanilla extract. So I blended it all together. So what you have to do is you transfer it into a bowl and you freeze it. So you put it in your fridge. I would prefer fridge and not freezer because I don't want it to turn into a rock solid. I want it to be more creamier. So just put it in the fridge for like an hour or so and you'll be good. So I see a hand raising here. Harshita, do you have a question?
Well, no, I just want to raise the virtual hand to tell you that we're blending.
Sorry?
I raised the hand because I wanted to tell that we're blending it, and it stays on for like a few seconds.
Oh yeah, great. So you were doing the ice cream with me. That's great. I have a partner here.
Yeah,
so
actually, Toby and Wilbur are also making. Isaac is also making, and they were just asking. It's few seconds blending, right, Sri?
Yeah, few seconds because bananas doesn't take a long time to blend, and you're not adding any ice to it. So yeah, it won't take a long time. It's just a quick blend. So I'll give you 2 more minutes to do that. If you have any questions so far, if you're curious to know about something, you can let me know while your friends are making ice creams.
Please feel free to ask questions. If you have any questions, either you can type in the chat box or you can raise your hand and unmute yourself and ask the question.
Harshita, are you raising the hand?
Yes.
Yeah, go ahead.
Yes. So did you mention who is the inventor of ice cream? Because I didn't hear if you did.
No, I said I will talk about it. Yeah, so once we made our ice creams, I'm going to talk about it next. So we will explore some history of how we ended up having an ice cream and what are some craziest flavors people have used to make ice creams. It's
Yeah,
really crazy.
and also in one of my magazines, the series is called Owl. You get it 10 times a year. There's a weird but true zone. And then one of the people invented ketchup flavored ice cream.
Yeah. So some of the flavors that I know what people used. And so let me tell you this. Let me take you through a bit of history of ice cream here, since everyone is.
Sri, I just would like to interrupt for a minute. Someone is asking how long they have to put in the fridge.
So in the fridge, just put for an hour. Again, don't put in the freezer. Just put it in the fridge for an hour. And then after an hour, you're happy to try it. Okay, Serena, I see a hand raised. Do you have a question?
I have a question. I didn't quite hear what did you need at the end for the two ingredients.
Two what?
The end of there was two ingredients and I didn't hear which
Okay,
one
so
was.
did you put bananas? Did you put yogurt?
Not yet, but I don't know the last two ones.
So the last two ones are vanilla extract. I just added 2 drops of it, and maple syrup. It's optional. If you don't have maple syrup, it's fine. You don't need to add it. Because I have it, I added it. So it's not necessary. So how long we keep it in the blender? So it's just like a quick blend, maybe like 30 seconds or 60 seconds. That's it. You don't need to blend it too hard. So yeah, and you can leave it in the fridge for an hour. So now let's get back to the history of ice cream that Harshita has asked. I see her hand raised. So first I'm going to answer the history part and then you can ask your question. Does that work?
Yes, but I just actually want to know, is it okay to, how many days can we keep it in the ice cream?
So if you have dates, you can put 2 dates into the ice cream.
Oh, I said days. How many days can we keep it in the fridge?
Oh, so okay, so you mean days. So days, as long as, I don't think, like, kids are so much into ice cream, I don't think you're gonna let it stay for at least a day. You're gonna be attacking it right away. So
yeah,
I would suggest like maybe 1 or 2 days, but don't put more than that.
Okay.
Yeah, great. So let's discuss the history of ice cream. So ice cream was actually first made in around 2nd century BC. This was like way long ago. So at that time, what people used to do is they used to take ice from when it snowed from outside, just add some sugar into it, and then they used to freeze it. They don't have freezers at that time. So they just used to leave it at some point and then take the scoops and eat it. So that's how people used to make ice cream. At that time, in 2nd century BC, actually, people have tried some very weird flavors of ice cream too. Like some of the ones that I heard were asparagus flavor, like, you know, putting asparagus into ice cream, breadcrumbs into ice cream, cheese into ice cream. I really don't know how I wouldn't really recommend doing that, but these are some very interesting flavors people have tried. Norman,
there is one question, Sri. I think they are making ice cream. So they have questioned, what do we do after blending again?
So once you're done with blending again, just put it in a bowl and put it in the fridge. If you have a popsicle thing with the popsicle molds, you can put it in the popsicle molds. But as long as you have, just put it in a cup and you can put it in the fridge. It's as simple as that. So again, coming back to the history of ice cream part. So after 2nd century BC, people have been doing this ice cream thing whenever it snowed. They're making these ice cream type of things, according to them. And even, in fact, Aristotle, who is one of the very pioneered person in the history, he liked ice cream. So even and like to the times of Aristotle, ice cream was very popular. Maybe they don't call it ice cream, but people basically use the similar ingredients to make ice creams. So the first ice cream was patented, like which is actually the brand of ice cream, started in 1700s. So we are in 2020s right now, so it's way long ago. From then, like people have been using different types of ice cream stuff, but I learned a very interesting thing. This is something that you all should know. When America won World War II in 1946, actually there was a documentation that I read that like the government has provided tubs of ice cream to every family in the America to celebrate the Second World War victory. So imagine that. I would be very happy if I had an ice cream party when COVID is away, and like I would really enjoy that. But yeah, that's the history part a little bit. So Hashita, did I answer you the question on history? Unfortunately, we didn't have who invented ice cream particularly, because it's something that has been popular desert since 2nd century BC. So we don't have who, but we know who patented the ice cream. Unfortunately, I don't remember the name of that person, but you can search it out. The ice cream was patented in late 1700s, and there was a scientist who actually patented the technology, and that's what have been used over the years by the ice cream vendors to make ice cream. So that's the interesting part. So let me tell you another interesting fact. Let's say you made your ice cream, you took it out, you're eating it, and then you are like, yeah, I'm done. I want to save it for tomorrow. So you put it back into the fridge and let it cool again, and you ate it the next day. One important thing for you to know is the texture of ice cream will be different the first time you eat it, which is today, and when you keep it at room temperature for longer time, it will melt, and when you freeze it again, the taste will be different because you don't form the same crystals. Again, the crystals chemistry comes here. So you can try it out. Just have ice cream today and leave it at home, let it cool down, and then put it back into the fridge and try it tomorrow. And you will see a difference in taste or texture. You see the texture, you make these observations, and you'll find some interesting things that about it. So I see no one said Nancy Johnson patented the first ice cream in 1800s. Yeah, that's correct. So ice cream was popular in 1700s, like I said, late 1770s, but I think the first patent was actually, it became like a business in 1800s. So thanks for the information, Novan. So now, since we have 20 minutes left, let's explore.
Raise the hand. I'm not sure.
Okay. Oh, okay, cool. Gugu, do you have a question to ask?
Maybe that was just my mistake, I guess. So we can continue.
No worries. So we will all now go into exploring the science of colors. So again, I'm going to ask you some nice questions about what you see. We don't hear you. Can you speak again?
Can
you hear me now?
Yeah.
Oh yeah, I can hear you.
Yeah. So so one of the first ice creams was invented in. Fun fact about ice creams is that when ice creams were made in China a long time ago, one of that's actually the reason why they were called ice creams was because ice cream in China was made when they took ice and then put milk and cream on it and let it freeze. Then they took it and ate it. That's actually where ice cream came from, the name.
Oh, nice. I don't know that. Thanks a lot for sharing that information. You're like, yeah, you seem to know more about me. So we should invite you instead of me to come to this session. Thanks so much. I really don't know that. That's very cool. Okay, so now let's go. So I'm expecting that all of you had whoever was making the ice cream blended it, put it into cups, and put it in your fridge. So let's now explore the science of colors for the next 20 minutes we have. I'm going to quickly share my screen. Can you all see my presentation? Okay.
Yes, it's all good.
Okay, the science of color. Let's see here. So now, who has seen a rainbow in person? Not in movies, but in person. Gugu, I saw your hand raised again. Do you have a question, or do you mean you saw a rainbow?
No, I mean I saw a rainbow in real life.
Oh, great.
A few
So
times.
who else saw a rainbow? I saw Serena raised her hand.
Harshita raised the hand.
And Harshita raised her hand. So yeah, I also saw a rainbow. And do you know why you see different colors in a rainbow? And why don't you see different colors at the same time elsewhere and only in the case of a rainbow? Okay, now let's explore that. So what happens is the light, I'm gonna quickly it's too many screens are open here. Okay, so what's happening in the case of rainbow is the light around us, what we don't see light, but like we expect that there is light all around us because it's not dark, right? So we call whatever we are in as light. So scientists call this light as white light. It's not that the color of the light is white. It's just that it's a natural term to say light. We call it as white light. So what happens is when the light actually goes through a prism, I will explain you what a prism is in a few moments. You will see the light will split into 7 different components, which is actually the visible light. So in the absence of a prism, you see light as normal, like you don't see any colors. But when it passes through a prism, you see the light will split into 7 different colors, and that's what you see in a rainbow. So you may answer like, okay, I do understand now, like white light, when it's split into 7 colors, you see a rainbow. But where is the prism in the case of a rainbow? So what happens is when you go near to a waterfall, for example, you see those droplets of water in the air, right? So those droplets of water act as a prism. And that's why when you go close to Niagara Falls in Canada, you see a lot of rainbows there, like when you're close to waterfalls, because the droplets of the waterfall act as a prism, which splits the light into 7 different colors. In the absence of those water drops, you don't really see those colors. And that's why rainbow is so interesting for us. So I told you, okay, white light, I told you when it goes to a water droplet, it splits into 7 different colors. That's what we see as a rainbow. But what is a color actually? So what happens is when you have sunlight coming in through this apple, so sunlight is a white light. So it has all 7 different colors in it. When it hits the apple absorbs some light, so absorbs some colors of the light. So and what happens is it absorbs some light, it gives off some light. So when you see as a red apple, like when you see a red apple, what you're seeing is the color the apple reflects. So let's say a lemon, for example. So why is lemon yellow? Because lemon is reflecting yellow light. Why is apple red? Because apple is reflecting red light. And that's why we see red color. Why is a leaf green? Because the leaf is reflecting a green light. So that's what the color is. Again, do you all know what I'm talking? What is the picture shown in this slide here? Okay, Serena, you raised your hand. Do you know what these are?
Serena, you can unmute your
Fingerprints.
Exactly. Guru, you also raised your hand. Do you have something to add?
Yeah, I was gonna say the same thing.
Okay, great. And I think Harshita also thinks it's the same thing. She also raised her hand. Fingerprints. We all know that each of us have different fingerprints. So my fingerprint is different from Harshita's fingerprint, is different from Isaac's fingerprint. So every one of us are different in terms of our fingerprint. And that's how people identify us. If they don't know who we are, is they see our fingerprints and then look into the data and see who it is. So my dad is a fingerprint specialist. So all he does is he catches the criminal. He goes to a spot where like a crime has happened. He collects the fingerprints and he knows which criminal has did it. So he catches criminals. He's a policeman. So that's what he does. Like we have fingerprints for humans, everything around us is made of molecules. Like if you ask a chemist like me, I would say we're all made of molecules, right? Molecules also have fingerprints, and that's what differentiates each of them. Let's take an example of a leaf. Leaf is green color, we all know that. And I told you why is it green color? Because it reflects green light, right? So why it reflects green light? So what is it making reflect green light is leaves are made up of a molecule called chlorophyll. So that's what is present in the leaves. This chlorophyll has a particular fingerprint. What that fingerprint does is, I showed like the picture towards the left side, you see a graph, you see several lines here. What those lines are basically the fingerprint of the leaf. So each thing, like whether it's a leaf or whether a carrot, each one of them has a different fingerprint. Scientists call it as spectral signature. We call it that's the actual term. We don't call it as a fingerprint. We call it as a spectral signature. So this spectral signature is different for everything around us. Let's say a leaf has a different spectral signature than a carrot. A carrot has a different spectral signature than an apple. And that's why we see different colors, because these molecules absorb some white light and just reflect a particular wavelength of light. And that's what we see. For example, chlorophyll in the leaf reflects green light, and that's what we see. So when someone asks you why leaves are green, you can say because it has chlorophyll, and chlorophyll reflects green light, and that's why we see leaves as green. So let's take an example of the season we are all in. We see some beautiful colors out there. And I told you leaves are made of chlorophyll, so it should just reflect green light. But why do we see different colors of leaves, especially in the fall? Anyone has any answer to it? If you have an answer, if you want to make a guess, go for it. Guru, do you have an answer for it?
Yes. So when it's fall, so some trees like evergreen trees you have a special coating on their leaves that prevents them from freezing over, but usually leaves will freeze over. To prevent that, trees will drain the chlorophyll. Like the tree can't survive in the fall, so it drains the chlorophyll from the leaves. So because the leaves can't be used anymore, and then so like the tree absorbs all the chlorophyll, and then the leaves fall down and change color because now they've lost that chlorophyll. They can't be green anymore.
Exactly. That's like so beautifully said. So let me explain to you for those who are trying to understand this phenomena. So leaves are green. Yes, every leaf will start green. We all know that. So what happens in the fall is we are entering into winter, right? When I say when we are entering into winter, we have less sunlight, right? So leaves need sunlight to make chlorophyll. It's like that's how chlorophyll is being made. So what's happening when you have less sunlight in the fall season, when you're approaching winter, the chlorophyll in the leaves starts to break down. Because the leaf can't make more chlorophyll, what happens is the green color starts to fade. But why do we see yellow and red color? And where does that color come from? So I told you leaves has chlorophyll, right? So leaves has all different compounds too. They have carotenoids, they have xanthophylls, and so much. I mean, I don't want to scare you with the names because I'm a scientist. I know what those names are and those interest me, but you don't have to remember all that. But what you have to know is once the chlorophyll in the leaf starts to degrade during the fall, the other molecules in the leaf will start. We also has a color, right? But what happens is chlorophyll is so chlorophyll kind of overpowers the leaf. That's why we see it as green, even though the leaf has another molecules which has different color. So what happens is once the chlorophyll starts to degrade, other compounds in the leaf, for example, xanthophyll, which actually reflects orange light, starts to take over chlorophyll. So when that happens is as the chlorophyll breaks down, you see orange color popping up because the xanthophyll, which is actually present in the leaf, reflects orange light. So since chlorophyll comes out, like is no longer in the leaf, xanthophyll is like, I am now the boss. I want the leaf to be my color. I don't want to be green because chlorophyll is out now. So that's what happens. And once it turns orange color, and yellow is also something similar. So we all eat eggs every day. So when you cut an egg open, you see the yolk, right? What color is the yolk? It's yellow. So what make the compound, the molecule that makes egg yolk yellow is the same molecule present in the leaves that makes it yellow. It's called Latin. It's called Latin. I can't pronounce it correctly, but it's called Latin. The molecule name, it's the same. So the yellow color that you see in a egg yolk, the yellow color that you see in a leaf in the fall are the same molecules. They reflect yellow light, and that's what you see. So, okay, you see green, you see yellow, you see orange, but there is something red. So where does the red color come from? So what happens is the colors that I told you, yellow, green, and orange, are actually present in the leaf. They're present in the leaf all the time. It's just that one color dominates at one part of the leaf cycle, the other color dominates at the other parts. But the red color is something which is very different. As fall progresses, leaf starts to create a new compound called anthocyanin. So this compound is actually not present in the leaf all the time. As the winter approaches, the leaf starts to make it. So that compound gives red color to the leaf, and that's why we see the red color. And that happens towards the end and not towards the beginning of the fall. So technically, before the leaf fall, you kind of see red color, and not like at the early stages. It kind of comes up after, but that's the chemistry behind the leaves. So you now know, you can tell your friends tomorrow why you see different colors in the fall. And you can tell them, hey, I learned this today, that leaves have these compounds which reflect different colors of light. So as the summer progresses, the chlorophyll in the leaf starts to break down. That's why we see different colors. And at some point, the leaf makes a new molecule called anthocyanin, which is red color, which gives red color to the leaf. And that's why we see before the leaf falls down, it's usually reddish color thing. Okay, we now know the leaf. Let's take a step back and explore fireworks. So we all love fireworks. I definitely do it. Although I like to see it, I don't want to do it myself because I kind of see it as a pollution thing and it's not good for the environment. But let's see why fire colors have different colors. So you have this, it's the same chemistry happening. You have the same materials inside, but it has different colors once it blows. You see like orange, green, white, silver, and yellow. So all this is because the fireworks contains metals. So these metals actually, when they are burned, they give different colors. For example, the red color is because of a metal called strontium. So when strontium is burned, it gives red color. Yellow color is because of sodium. that's when sodium burns, you get yellow color. Green color is because of barium. All these are different metals. If you don't know what all metals are, you don't feel bad. I mean, this comes very later in your school. At some point, you'll learn about metals in your education. So you can leave that part there, but you now know why you see different colors, because they're different metals and each metal has a different color in it. Okay, so I think how long I have? No, and how much time I have?
Yeah, we have 5-10 minutes more.
Okay, 5 minutes is good. So I'm almost towards the end. So I told you that the light surrounding us is the white light, right? I told you we call it white light, and when it like passes through a prism, you'll see different colors. And you also know what these different colors are, is just the molecule's signature, like a molecule's fingerprint, basically. Each molecule has a different fingerprint. That's why we see different colors and stuff. So let's look into the color, into the light, which we don't see. So I think someone asked this question that I don't remember, what can we see all colors or something? I don't exactly remember that question, but that's okay. So the light that we see around us is the white light. We call it a visible light because it's visible to us. We know that there is light, but we just don't see the colors. But there is also invisible light, so which is called infrared light and the UV light. So the UV light is the invisible light and the infrared light is the invisible light. But generally, whatever the light that comes from sun also has all this. So it has the visible light, it has the UV light, and it also has infrared light. Basically, but the light that we see is a visible light. We just don't see invisible and invisible light. So let's say it's very sunny outside and you want to play, you decided to play with your friends in outdoors. So what did you apply to your skin before you go out of your house? There is something that you apply on your skin. You can let me know if you have.
You can raise your hand, yes.
There is something that you apply on your skin when you go out to play in the sun. Yes.
Yes.
Harshita, I see your raised hand, and also Guru raised her hand. Any one of you can say.
Sunscreen or sunblock.
Yeah, sunscreen. Yeah, that's correct. Guru, do you have the same answer?
Yeah.
Okay, great. So sunscreen, right? Why do we apply sunscreen? Because the sunlight also has invisible light, and one of the invisible light is called UV light. So this UV light is bad to your skin. You don't want to be exposed to UV light. So in the summer, when the sun is so intense, you just want to protect your skin from this UV light because you don't see it. You don't know if you have to apply it or not. That's why, as a precautionary measure, we were always told that before you go out to play in the sun, you have to apply sunscreen. So what sunscreen does, it reflects the UV light so that your body doesn't absorb it. So basically, you're minimizing your body's interaction with the UV light by applying the sunscreen. It's just like a shield on your skin that can prevent your skin getting exposed to the UV light. But this is for us humans. But there's an interesting insect around us which can see this invisible light. Honeybee. Bees can actually see UV light. So when you see a flower, you see, let's say you see a rose color flower, a rose, right? Let's say you see a red rose. You see the red color, you know that it's a rose. But for a bee, what bee sees is not the red color. What bee sees is actually, let me give you more clarity here. You know where the bee you know what bee does to a flower, right? It goes into the middle of the flower and it sucks the nectar. You know why? How it knows that it should go to the middle of the flower? Because the middle of the flower actually has some compounds which absorb UV light and they give some color. Because we humans cannot see UV light, we don't see that color. But bee, because it sees UV light, it sees that color. That's why for a bee, it actually knows that it should go into the center of the flower and not to the sides of the flower where there is no nectar. So bee is very smart because it can see the UV light. The flowers are really making the bee go to the right spot. So that's like, this is something that it's very interesting for me to know that bees can see UV light. But it's also interesting that that's how bee know where to go in a flower, because it sees that middle part, which kind of gives a color in the UV light, which we can't see, but a bee can see. Okay, so I told you that there is an invisible light called UV and infrared light. So some molecules also absorb this UV light, like apple absorbs visible light and gives red color. Some molecules also absorb the UV light and gives a color. It's just that we humans cannot see that color in specific circumstances like a bee does. Let's take an example of a jellyfish. In dark, when it's nighttime, jellyfish gives a color which we humans can actually see, because it looks like a glow, right? So the reason for that is jellyfish contains molecules called green fluorescent protein, which absorbs the invisible light and gives a color. And that color is seen as that glow that appears on the jellyfish. So similarly, like a jellyfish, spiders also absorbs UV light and gives a color which is shown in that glowing spider. So when it's a nighttime, like if you have like a black light with you, I will show you what black light is. And if you shine it on a spider, you will actually see the spider glowing, which is not visible in the daytime, but definitely in the nighttime. So we all have pets with us, and we all know pets do pee at random locations in the house. So it's really hard to detect them, right? So like scientists use something called, I'll show you what they use. I have it with me. So this is the invisible light. So I can still see the color of the light because it's just a false color. It's not the color of the light. It's just a way of saying that there is some light there. So this light is actually the UV light. So when you shine this UV light on a pet pea, the pet pea contains some compounds which absorb the UV light and gives a color. And that color you can still see. So in a carpet, like in a regular carpet, you may not be able to identify pet peas, but like when you turn off the light and shine some UV light on the carpet, you will see the stains very clearly. So similarly, like in case of currency notes, like let's say US dollar notes, each dollar note has a strip in it which is used for identification purposes. It will tell you if the note is real or fake. So this each dollar note has this strip, and this strip, when you shine UV light on it, it will give a color. And that's how you identify if the color, that's how banks identify if the note is real or fake. So I know this is a lot of information, but I just want to give you some examples of what scientists do using UV light. Is they detect if a currency is fake or real. They can know. They can see if a pet, if your cat or dog has peed on the carpet. Like I can totally see. I can come to your house and see and can tell you that your pet has peed in the carpet without you knowing it. So this is something that I use in my lab. It's the UV light thing. So what this light does is it gives you UV light, which some compounds around us, like I showed a spider or like a jellyfish, when you shine this light on it, you will see them glowing. I mean, this is just another way of showing colors. So the colors are not just the colors what we see. There are some invisible colors too. And to see them, you need a special light for that, which I use in my lab to actually see colors of compounds. So I will close it here. I hope that's good enough. But if you have any questions, do let me know. I'm happy to answer your questions in the next 3-4 minutes. If you don't have any questions, you can tell me what's the most interesting thing you have learned today.
So just unmute yourself, Harshita. Just go on, unmute yourself.
The
And
most interesting thing I figured out today is about the very crazy flavors of ice cream.
Yeah. What about colors? What's the interesting thing you have learned about colors today?
The interesting thing about colors is that if you can shine a UV light on a spider or anything, it'll glow.
Yeah. And you can't see it normally, like with your eye. You need UV light for that. Yeah. Cool. Toby and Wilbur, I see your hands raised.
yeah, please unmute.
The most interesting thing that I learned today is that you can use a UV light to see cat pee.
Exactly. You can use UV light to see cat pee, but I won't recommend you to use UV light because you need some adult. You need at least, I mean, because you're kids and you don't know how to use that light, it may not be good for you. You need some adults around you to make sure, like, to help you see that. But I wouldn't recommend you using these UV light things as kids. Like, it's something only adults should do just because they know how to handle it.
Christina is saying she found interesting the types of ice cream.
Yeah.
And Isaac is saying that all probably everything. So these are the comments. And Harshita, are you raising your hand? If yes, then you can unmute yourself.
It's a question.
Yeah.
So I have a UV pen. You know what UV pens are, right? They have invisible ink. When you shine a UV light on it, you can see what you wrote.
Sorry, what did you say? What's your question?
A UV pen. I have a UV pen. So
Yeah. You can actually see pet stains with it. Just like turn off your, like, again, this you can't do this all by yourself. You can ask your parents to volunteer you. You can turn off all your lights in your house, and if you see some pet, if you want to check your carpet, you can just shine that on your carpet and see if there are any traces of pet pee or something else on your carpet. It's pretty visible. You know what I would do? Since this is something that I carry with me all the time, because UV light is something that I use as a scientist too often. I actually, when I check it into hotels, I actually use this light to see if the bed sheets are clean or not. Because if someone like sweat or like either sweat or saliva or something like that on your bed sheet, when you shine it, UV light on it, you'll see the stain very clearly. So that's how I know if the hotel is clean or not.
Yeah, but we don't have a pet. So if I use a UV light, is it safe to use alone?
No, it's not safe to use alone just because it's not good for you. That's why I said you always should have some adult supervision for that. You're too young to use it by your own.
Okay.
So if you're interested to find out, you can always ask your parents or your elder cousins or anyone who is elder, like who's an adult, to help you so that you can at least see staying by the side, just watching it rather than handling it, right? I mean, it's still good, okay, to watch it, but I don't want you to handle it by yourself without adult supervision.
Okay.
Anyone else has question? If not, then should they try their ice cream now or not? Or should they?
Well, I think I will leave it for an hour, right? So I would leave it until 5:30. They can do it by themselves, and they can let us know. Maybe they can write to us. Like I told you, you can actually do the demonstration, like an experiment that I told you. Like, taste your ice cream today, let it cool down, like let it really cool down, freeze it again, put it in the fridge again, and then taste it tomorrow and see if you see any difference in the texture, if you see any difference in the taste. Is the sweetness reduced? Or, like, you should be very careful, like just pay attention. You'll find some differences for sure. Cool. Okay. All right then.
Okay, so
Thanks everyone for being with us today. I really had fun. I hope that you learned a lot of things, and feel free actually to go to your friends and your younger siblings, if you have one, to tell them why you see different colors in the fall. Why does leaves suddenly change colors in the fall, which you don't see in the summer or the spring?
Serena, do you have any question? Because you raised your hand. If you have, you can ask. You're muted.
Did you tell us you would show us how to make colors?
No, I didn't tell us. No, I think it's a confusion. I just want to show the session in different parts. One is the colors part, where I will tell you the science behind colors. And the other one is the ice cream part, where I'll show you how to make an ice cream. And I'll also tell you what makes ice cream so delicious, which you all learned today.
Oh.
Yeah, that's what I think it's because they are both clubbed together. There's some misunderstanding there, but yeah, I delivered what I promised to no one today.
No, that's true. It was only about hands-on activity for ice cream. That's what was written in the description too. And for the colors, it was just to show you like what's the science behind the colors. Mainly the hands-on activity was for ice cream. So I hope you all probably will enjoy your ice cream later on. It seemed very delicious for sure.
Great. Okay, then I'm signing out. Thank you everyone for joining, and hopefully you had a good day. So enjoy your weekend with your own handmade ice cream.
Okay, thanks,
Okay,
Shri, and
bye.
thanks for joining. And everyone, if you have question with Shri, you can always write us email, okay? So you can always
Okay.
let us know that and how your ice cream tasted or any review. Thanks.
So
Shri, for
where do we write the email?
you have my email address because I sent email today or the list of ingredients and also the Zoom link separately, so you can use that email ID. With I don't know which email ID you used for registration. So I sent an email today and I think 2 days back too. So you should have that. You should have mine.
Yeah.
Okay, thanks everyone. Thanks Shri for coming, for taking out time. I know it's very hard for you. You are just near your dissertation. Soon to be a doctor in chemistry. And thanks again for coming and
Thank you.
making room for us. Thank you. And have a great day, everyone. Have a great evening and take care. Bye.
Bye.